So December 1st, they tried to release version 2. They tried to release version 2. Okay, Department of Defense has pro- developed a project and released version 1 on January 1st. They did so many changes between this, and they tried to release version 2 on December 1st. Unfortunately, this was failure. Okay, and this got success. First version was success, and the second version was failure. Okay, so they try to fix the issues and make it as working fine. They tried their level best. Okay, work for quite a long time. Still, they were unable to fix these issues. Okay, they were unable to fix this issue, and at the same time, they tried to roll back their changes back to the version 1. Even that rollback, they were not able to do. They were not able to fix this issue, and also they were not able to roll back the changes to the previous version, previous changes. Then they had realized, okay, so there is a flaw here. Okay, some process has to be introduced. Something is lagging here. Okay, so someone has to keep tracking our changes. Someone has to keep controlling our changes. Okay, there must be some process here which will help us to track, which will help us to control our changes in the project. Okay, so that is how they introduced system called software configuration management. Software configuration management. Okay, this is a process. Okay, SEM is a software engineering process which will help us to track, control all the configurations in the project. Okay, which will help us to track and control and this will help us to enable the parallel development. This will help us to generate the reports, audits. Okay, help us to, especially if I say two core tasks, it will help us to enable, track, and track and uh, reproduce, rollback. All these features can be enabled using SCM tools. Okay, track and controlling the software configuration changes. Okay, this is a software engineering technique to control, track all the changes in the project. Okay, so there are several tools. There are several tools which helps us to implement SEM. Okay, so where this SEM exactly works in SDLC, where this SEM exactly works in SDLC. SDLC we know, right? Requirements gathering and analysis, design, design, coding, testing, and release. Okay, so this one and this SDLC, it SCM team especially works between coding and testing team. Coding and testing team. Okay, so how this cycle works here exactly? Okay, let me explain. So development team will modify their changes and commit their code in the SCM tool, and then they will do the build. They will give the code to the SCM team. They will do the build. Okay, so as build management, using the build management tool, they will do the build and generate the var file, binary file, and deploy it in the testing environment. Okay, testing teams will start evaluate this thing. Then if there are any bugs, they will report all these bugs in the Jira or bug tracking tool. And then again, these are the inputs for the development team to fix all these issues. Again, they will go for the next changes, do the commit their changes and do the build, deploy in the test environment, and at the testing team as usual, they will test this application, and there are any issues, fix it. Okay, this cycle will keep continuing. This cycle will be keep continuing until and unless these issues are fixed. Okay, once these are all done, once these are all deployment testing, everything is done, then only they will go for the next environment. They will go for the release. Okay, they will go for the release. That means we are moving to the production environment. Okay, moving to the public. Okay, so that is how this cycle will be keep running. Okay, tools are like, okay, there are several tools in the market like SVN, Git, GitHub, okay, TFS, ClearCase, Perforce. Several tools are there. Serena, PVCS, several tools. Okay, so let's start talking about SVN today. Okay, so SVN is an SCM tool. SVN is an SCM tool which will help us to enable the version management in the project. How exactly this version management works for us? Okay, so what is a version? First of all, let's understand what is exactly the version and how it works. Okay, right. So this version management, this version management, okay, helps us to enable the centralized repository. Okay, version management helps us to enable centralized repository. Okay, what does it mean? What is the use of this? Right? For example, okay, there are 100 developers. There are 100 developers. Right. Where can they store the project code? Where can they store the project code? Can they save their project code in their local? Okay. If he is storing in his local, what about he? He also has to store in his local. He has to store. Right. Tomorrow, if he is left, or how can collaborate these changes? How can all these developers can collaborate their changes? Right. So saving in the local is not the good idea. Okay, right. So instead of that, let's give a shared folder. Let's give a shared folder. Okay. So you shall ask us everybody to work on it, right? So today they have created one.java file. Okay. So tomorrow, one developer has came and deleted this or deleted the content of that, right? So will we be able to track all the versions? What was the previous thing? What is the current one? What was the previous one? In the shared drive? No, we cannot track all the configuration changes, right? So we we still don't have the correct solution here, right? To save our data. So that is why what SCM team, what SCM is recommending, okay, let's SCM team, this version management tool will provide one one centralized repository, okay, where this repository can be accessible by all the developers, where this repository can be accessible by all the developers. Okay, let's assume this is the developer one mission. Okay, and developer one. Okay, so he will be able to access this repository. First, he will do checkout. He will do this is checkout his repository to local local workspace. Okay, so he will check out this, he will do the modifications, then he will commit his changes back to the repository. He will commit his changes. Okay, or in few tools we call it as check-in also. Okay, commit or check-in. Commit the changes from local to repository. Repository will store all the versions. Okay, so it will store the version 0, what was the content, version 1, what was the content, version 2, what was the content. Okay, for that project. Okay, so like this, it will serve every version. Okay, even if for example developer 3 has done some changes. Okay, he has checked out his code and did some changes and committed that, so that it will create the new version 3. Version 3 is the latest. Okay, so for that entire repository, for the entire project, okay, for that entire repository, it will create the version for every commit. Okay, so how it will help us, right? Tomorrow if you want to roll back, if version 3 is not good, okay, if you want to see the history version 2, you can always go back to previous version, you can always go back to previous version. Okay, so that is how it works for us to manage all our configuration changes. Okay, that is how we can also track all the changes, like what was our previous change, what was the initial stage. Okay, and and also and also, right, how it is exactly works here is it will work on the delta concept. What is delta? Okay, let me explain you here. Okay, let's assume I have a file 1 dot java 2 dot java java. Right, so we have 3 files, let's assume. Okay, so every file will have the initial version. Okay, let's assume initial version is 1. Okay, then he has modified some changes. Okay, in the initial version, let's assume we have added 10 lines of code. 10 lines of code. In the next version, developer 1 has did some changes and committed. In the next version, he has added 2 lines. Okay, plus 2. Okay, so as part of this version, it will save only these 2 lines. Okay, as part of this version, it will save only 2 changes. Okay, and again in the next version he has modified, okay, 3 lines. Okay, only 3 lines. Okay, so these 3 lines become delta. These 3 become delta. Okay, so delta is nothing but the difference between two consecutive versions. Right, so every for every file, okay, every file there will be several versions. Okay, there will be several versions. Okay, so what SVN will do, it will save initial data, and then hereafter it will only save delta of that file. Why it is only saving delta, right? So if it has 10 lines already, 10 lines are there, yes, I added only 2 lines. Why do we need to save all 12 lines again? Right? It's waste of memory, right? It's a waste of memory. Again, here 10 lines already saved, again 12 lines. Okay, duplication of that lines has to be saved. So that is why instead of to avoid the duplications, what SVN is recommending, what SVN uses the logic here is to store only the delta of the changes. Okay, so that will help us to save the memory. That is what SVN is following. Okay, so different tools will follow different techniques to store. Okay, store the data. Okay, SVN follows this delta process. Okay, right. And also and also version management helps you to roll back their changes. Okay, this is one of the important feature. Enable a central repository. Okay, we understand that everybody will be accessing single repository and everybody will be doing the changes into the single one. Okay, so in future if you want to get the data anytime, you can only refer this one. Automatically you will be able to get the complete data. Okay, and then okay, reproducibility, this is also one of the important feature. Okay, right. So reproducibility is one of the important feature. Reproducibility is also one of the feature. Right. What does it mean, reproducibility? Okay. So you have hundreds of files. You have hundreds of files like this. Okay. Let's assume you have tagged the code. You have tagged the code. Okay. With version number 1.0. This is version 1. Or tag 1.0. Tag 1.0. Okay, and then you have developed the versions and keep adding more many features. For the next version you have tagged one again, tag 2.0, tag 2.0. Like this you will be keep adding the tags for your repository, where as and when your project has reached some milestone, then it's always good practice to apply a tag. Okay, so how it will help us, right? So in future you want to refer, okay, maybe let's assume tag number 90 now. Okay, you want to refer what was the code we deployed, as part of the tag 1.0, version 1.0, right? You can always get the source code of tag 1.0 using tag of 1.0. Okay, using this tag you can get always. Okay, name can be anything, just for the remembrance I have given tag. Okay, it can be milestone 1.0 or it can be some xyz 1.0. Okay, name can be anything here. Okay, anytime you can refer this tag. To make it easier for you, I have uh, several balloons here. Okay, let's assume A, B, C, D, E. Okay. I have a balloon one. I have one second balloon. This is two, and I have another one. This is three. Okay. So if I pull the thread three, if I pull this thread three, okay, what are the balloons I will get? I'll get B, C, D, right? If I pull tag 2, what are the balloons? B, C. If I pull this one, I will get A, C, what is this? E, right? E, right? I'll get these three, right? How I'm telling, because I have applied the same tag on these three balloons. Okay, same way here, I have applied the tag on the different versions of different files with the same name. Okay, tomorrow if you want to fetch what code has been deployed as part of this version, as part of this release. Okay, you can always fetch the data. Okay, using this one you can compile this again. Okay, and again deploy this version 1.0 binary anytime in future. Okay, so this is what their failure, US Department of Defense, right? If they have this technology, if they have this process in their system, they would have easily rolled back their changes. Yes or no? Okay, they would have easily rolled back their changes and they can spend the valuable time for fixing the issue instead of spending time for rollback, right? What they would have done, they would have first version, the January version, they would have applied version 1.4, and for the next version, they would have applied version 2.4. 2.4 is failure. So what they can do, they can always get the code from tag 1.0 anytime in future and compile this code and deploy this one into the environment. That's it. We can reproduce, we can regenerate the old artifact, okay, anytime in future. Okay, that's called reproducibility. That's called reproducibility. And parallel development. Parallel development. What is parallel development? Right? Parallel development is also one of the important feature which is providing by version management for us. Okay. Parallel development, the meaning you know, right? Okay. So multiple teams has to work, okay, without any conflict, uh, each other. Okay. So multiple teams should be able to uh, work on the project, work for the project, okay, without any conflicts between the teams, okay. How it is helping us, how it will help us, right? So if you have a repository, what they will do, they will create multiple branches. They will create multiple branches. They will create multiple branches. Okay, branch 1, branch 2. This is repository. Okay, so what they will do, uh, maybe development team works here, and production support team works here. Production support team, okay, production support team, okay, works here. And so, sorry, branch 1 and branch 2, right? Branch 2. Okay, so as soon as their changes have done, fixed everything, their changes went to live, that means production. Okay, then these changes will be merged back to the repository. And if these changes have gone to the production again, these changes also will be merged back to the repository. Okay, so here, this is how it looks like. Okay, so they will create the multiple branches and give it to multiple teams to work on their future, to work on their future. Okay, maybe this guys, this team is working on the future one. This guy is working on the future two, future three, like that. Okay, by creating the multiple branches, we can enable the parallel development. Parallel development. We'll see all this practically. Okay, right. And tracking. Okay, tracking. Okay, as usual. Okay, we can track each and every change for each and every file. What was the previous version? What was the initial version? What is the difference between version 2 and 3? Right, each and every change of the file, lines of code, every line can be tracked. Who has done committed, who has committed this, what was the changes, right? And for what fix he has fixed these changes. Okay, all these things can be tracked. And also here we can also generate set of statistics. Okay, set of statistics, kind of auditing. This will help us to audit our repository. Who is very active user, who is keep on adding the modifications, right? And all can be tracked here. Okay, and security. Okay, so security, our repository, our project code should not be accessed by some other else, right? This should be only accessible only for our team. Yes or no? Okay, so they will have the feature to enable n number of users and also give the access permissions based upon their needs, whether he wants read access, whether he wants read and write access. They will create set of groups. Okay, groups like testing group, groups like development group, groups like production support group. Okay, maybe for development, read write they want. Production, production support they want also read write. Testing team, they just need only read. Automatically, as and when some user has joined, that user will be added to the respective group so that that respective permissions will be enabled for the respective user automatically. Okay, so they will have users and groups to enable the security in the project. Okay, so none of the that users can be access this repository. Okay, cannot be accessed. Okay, if you are not part of that ACL, okay, access control list. Right, that's about the version management introduction. Okay, let's understand the version management vocabulary. Let's understand version management vocabulary. I hope you understand what is delta, right? And let me write all this. Okay, right. Now let's understand the vocabulary of version management. Okay, so you know what is repository now? A repository is a centralized location where everybody can store the data. Okay, it's a centralized location. Okay, and what is a branch? Branch is nothing but which branching is a feature which will help us to enable the parallel development for your project so that multiple teams can work on the multiple features parallelly, right? And what is commit? Commit is nothing but committing the pushing the changes from your local workspace in the sense the local directory where you are working. Okay, pushing your local changes, developer changes to the server. This is server, this is client always. Okay, SVN is a client server model. Okay, SVN is a client server model. Okay, so everybody will be accessing server. Okay, so from pushing for changes from local to server is called as check-in or commit. Reverse, getting the changes from server to local is called as checkout. Okay, hope you are clear about check-in and checkout. And delta you are very clear. And difference between two consecutive versions is called as different code difference. Okay, code difference between two consecutive versions of your file is called as delta. What is version? What is version? Every commit. Okay, for every commit, for every check-in and check-out. For every checkout and check-in, it will generate one number. It will generate one number for your comment. Okay, that's called as version. And what is workspace? Workspace is nothing but it's a developer's local working directory. Developer's local working directory. Okay, and history. History is nothing but you can see the log. Okay, you can see the log. Okay, and what are the versions? How many versions are there? What was the changes was done? Okay, everything can be seen in the history of that respective file. Okay, what is tag or baseline? Tag is nothing but it's a snapshot of the code. Remember, it's a snapshot of the code. Snapshot of the code. Okay, and so this will help us to enable the reproducibility concept. Reproducibility concept. Anytime you can refer the old version in future. Okay, so rollback. Okay, if you want to change your if you want to undo your changes in the current one and go back to the previous one, you can always go for the previous version using rollback option. Merging is one of the word which we use is here. Merging is nothing but what happens here is okay, merging is nothing but two versions of the file, okay, making it as a single one. Okay, so here two some changes are there, here some changes are there. Both are 1.java, both are 1.java, 1.java, but both have been developed by developer 1, developer 2 has developed this. Okay, combine all these changes, combine the changes of this and making it as a single copy is called as merging. Okay, so merging is nothing but two files, two different versions of the files, merging it and making it as a final version is called as merging. There is one more type of merging here. Okay, and I will explain in the next concept. Okay, so merging in general, merging is nothing but combining two things and making it as a single one. Okay, it's called as merging. Okay, let's try to understand the branching structure. Okay, branching structure. Okay, so there are different types of branching structure. Different projects will follow different structures. Okay, so there is one thing is like stable trunk. Yep, trunk we call repository as called trunk here. Okay, especially in SVN we call the repository is called trunk. In Git we call it as master. In Git we'll call it as master. Okay, so here in SVN we call it as a trunk. If it is Git, we call it as master or stable trunk and unstable trunk. Okay, so there are two major branching structures, okay, which we should generally understand this. Okay, what is a stable trunk, unstable trunk, right? What is this? Let's assume you have a trunk, you have a trunk here. Okay, you have a repository here. Okay, um, developer keeps doing their changes in the repository. Okay, at some point, you know, uh, do you remember they will have a release plan when I was given in the introduction, right? So every they will have a release plan for every release, like let's assume every month they have a release, okay. So in general what they will do for every release they will create a branch. Okay, they will create a branch. Okay, so this is for Let's assume this is for Feb 2018. Feb 2018. Okay. For this release, they will have created the branch. Developers will start doing the changes instead of doing in the repository, they will start doing the changes in the Feb 2018. And once they have done, these changes will go to all the environments like ITG, QA, okay, cert, and then prod, okay, and dr, okay, every environment. Once this has gone to the production, what they will do, once it has gone to the production, that means our code is finalized and it's working fine, and then they will merge these changes back to the repository. Okay, they'll merge these changes back to the repository. And also then for the next release they will create one more branch for March release, March 2018. Okay, and then again developers will start doing the changes in this branch. They won't do the changes here, they won't do the changes here. Okay, they will always do the branches in the release branches. These are all called as release branches. Every release they will create the branch and do the modification and deploy in all the environments. Okay, and then they'll merge the changes back to the repository. For example, okay, for example, they have a hotfix for this. What they will do, they will they will create one more branch here that is called as hotfix branch. Okay, or either they will create from here or they will create from here. Okay, they will create from here. Okay, and make it as a hotfix branch. Okay, they will make it as a hotfix branch. What is hotfix? Okay, hotfix is nothing but unexpected issues. Hotfix, okay, unexpected issue which needs to be immediately fixed it. Okay, which needs to be fixed it very immediate. Okay, immediately, instantly. Okay, so these kind of issues we sometimes it comes. Okay, so they will create that hotfix branch for the March, like March 2018 underscore hotfix. Okay, hotfix, and they will do the hotfix changes here, and then again they will changes push back to the merge the changes back to the repository. And then again, as we for the next release, parallelly they will also have one more branch for the April. Okay, like that for every release they will create the branches, do the modification, and push the changes to the environment. Then once everything has gone to the production, then they will merge the changes back to the repository. Okay, so this is called as stable trunk process. Stable trunk. That is right. And now let's try to understand how that unstable trunk looks like. Okay, so what will happen here? They have a repository. Okay, it's about unstable trunk. Okay, the what unstable trunk. They have a repository. Developers are keep doing the changes here. Okay, for developers will keep doing the changes here. Okay, and once the changes has gone to the environment production, what they will do, they will create a tag, they will create a tag, or they will create a branch. They will create a tag or they will create a branch. Okay, they will create a tag or branch. This is for January. Let's assume Jan 2018. Okay, and then for the next release, they will still continue the changes. They will still continue the changes in the same branch. Okay, and they will still continue the changes for the February also. Once that these changes have gone to the all the environments, again they will create one more branch. Okay, that is Feb 2018, and then for the next release, again they will be keep doing the changes in the same trunk. Okay, and then again it has to go to all the environments. Then again they will create one more, right? So like this, they will be always doing the changes in the repository. Instead of using the branchings, they will always doing the changes in the repository. Okay, so 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 if you can see the trunk here, trunk is always getting modified. It will be every so many commits are happening. Okay, everybody is keep doing the changes in the trunk only. That's why we call it as unstable trunk. Trunk is keep getting updated every minute. Okay, so it is not stable. Okay, so in this one, in this one there is a some disadvantage here. Okay, so the thing here is you cannot enable the parallel development because you have only single source of commit here, right? You are only working on the trunk. Okay, so for one project there will be only one trunk. Okay, there will be only one trunk. Okay, so you cannot enable the parallel development if you go for the unstable trunk process. Okay, this will one advantage here is you don't need to go for the mergings. Okay, here you have to go for the mergings. As soon as it has gone, it has to be merged. Okay, some additional work here. Okay, and this at some point, this will help us to enable the parallel development. Okay, but this one, it is easy, and it is not helps us to enable the parallel development. Okay, so I can say this one helps us to helps us for the small projects. Okay, and where they have only single team, where they have only 5 members or 4 members. Okay, in that case they can go for the unstable team. If they have multiple teams, they need to work on parallelly. If they have hundreds of developers, okay, needs to, in that case, they can always go for the stable trunk. Okay, especially when you go for the agile process, it's always go for the stable trunk process. Okay, clear everybody so far?
Yes, Subbu.
Everybody?
Yes, sir. Yes, sir.
Yes, Subbu.
Right,
Yes, Subbu.
right. Very good, very good. Okay, so that is the background of SCM and version management. Okay, so I hope you understand what is the core functionality of version management. Okay, now let's take a look into the small PPT now. Okay, let's try to refresh our content. Okay, right. So SVN. SVN is a what is SVN? What is SVN?
Subversion.
Subversion. What is this? What is subversion?
It's a version control management.
Exactly, version management tool. Okay, Subversion is a version control system. Okay, a version control system allows the users to manage the files, directories, and the changes made into the repository, right? Sorry, in the files. Okay, and Subversion can manage any sort of file. Okay, it can be it means to say it can manage binary. It can manage binary files. It can manage um, uh, ASCII files, right? Any kind of file can be managed in the Subversion. Right. So here this is how it looks like. Okay, repository you'll have, and all the developers will have working copy, and over the internet or intranet, you'll be accessing this repository into local and doing the modification and commit the changes back to the repository. Okay, client servers model. And reasons to use the subversion, right? I hope you understand all these features, right? So you can easily work with the developers, right? And you can undo the changes, restore anytime, right? And subversion is well known. It's a free tool. It's a free tool. Subversion has been under the development since 2000, right? And subversion architecture. This is how subversion architecture seems to be. Okay, so a client, okay, the client can be this client can be either GUI or CUI. Okay, you can access the subversion either GUI or CUI. Okay, GUI if you are in Windows. If you are working from the Unix, then you might have to use commands, SVN commands. Okay, and what will happen internally when you run some command or when you run some something in GUI, then automatically it will refer the SVN client libraries. Okay, client libraries. And once it has run, this will access the repository of SVN, and then it will connect with the over the internet. It will connect for the SVN server. It is a program. It is a server program. SVN server program, which will manage, which will manage the, it will manage the repositories. It will manage the repositories. Okay, so internally it will have a database. Internally it will also have a file system. It will have a one file system and one database. Berkeley DB and FSFS is the file system. Okay, so server, this server program for every repository, it will create one file system and one database. Okay, if it is another repository, again one more repository and one more file system, one more, again one more, like this. Okay, SVN server will manage all these things. Okay, so every repository will have, okay, um, will have one database and one file system to store the database. Okay, so whenever you send some request, it will go to library. You will refer the library repository access. Okay, whether they have access or not, and then go for the internet, go for the SVN server program, connect to the repository, and fetch the data and give it back to the user. This is how the flow seems to be. Okay, and right. And repository versus working copy. I hope you understand what is repository and what is working copy. Repository is something about centralized location. Working copy is local to the developers. Okay. SVN. You understand what is checkout, commit, merge, right? Checkout is nothing but getting the changes from server to local. Commit is nothing but reverse. Okay, from local to server. Merging two versions of files, making it a single one. That's called merge. SVN trunk and branch and tag. Okay, these are the three things which you must know, right? What is a trunk? Trunk is a repository. Branch is nothing but, branch is also nothing but it's kind of a small repository where you can work for the specific feature. Okay, specific feature. Whereas trunk is for entire project, overall changes for the for your project. You can always get it from the trunk. Okay, tag is a snapshot. You can always roll back your changes using the tag. Okay, and differences between the versions. Okay, each version of the file will save the delta, right? So delta is nothing but the changes between the two versions called delta. Okay, atomic commit in the sense you have modified 10 files. Okay, and you are trying to commit, you trying to commit all the 10 files. Okay, and if for example 10 files, two are committed, two are not, and remaining eight are not committed due to the network issue something. Okay, so what SVN will do, okay, either it commits completely all 10 commits or it rollbacks all the changes. Okay, commit, do it fully or don't do it. Okay, so that's called atomic commit. Okay, it will be doing all the commits at a time. Okay, and properties, you can set a number of properties are nothing but keys and values. Okay, and you can like these properties will help you to track all your files. If this file is in which stage of this, even your repository, whether it has gone to the down to the so on so on so. Okay, properties are nothing but setting up the variables in the repository. Okay, binary versus character data. Okay, subversion expresses file differences using the binary differentiating algorithm, which works identically on both binary and character-based files. Okay, so SVN supports both binary and character files to manage this version files. Okay, both type of files are stored in the compressed format in the repository. Okay, internally it will store in the compressed way. Okay, but whereas CVS, it is another tool. It treats these files types as different, but SVN treats as a same file, even it is a binary or character file. Okay, the the fundamental problem. Okay, the fundamental problem here. Okay, let's try to understand the problem here. Okay, user A gets a copy of file X from the data. B gets file. Okay, A changes X and writes a new X back to the database. User B changes his older version of X and writes into the right. So these fundamental problems and copy, modify, merge, these things. Let's see after taking some practical session. Okay, we'll see this slide. We'll take look into these slides later. Okay, this is not the right time, right? So we will see practically. Okay, let's take a small break, then we'll go for the practical session. Okay. Okay, so before we go for the practical, okay, we must have two softwares. Okay, so one is server, one is client. Okay, for server we are going to use Visual SVN. Okay, for client we are going to use Tortoise SVN. I Tortoise SVN. Okay, so these are the two softwares we want to install here. Okay, so these softwares are very straightforward. Just next. I have also given the document to install this. Okay, one second. Installing Ubuntu Visual SVN installation. Okay, these are the links from where you can download it, or these are the things. I will share this document. Do you guys have got the portal access?
Yeah, but nothing has been added yet.
Right,
I mean,
right,
no
right.
class, nothing. So,
Okay. It will. I will add it today. I will make sure that. Okay. So for Pranavi and Amit,
okay.
okay, I will share this document, right? And so just download these things, download these two, and make sure the prerequisite for these two softwares is Java. Okay, Java must be in your system. Java is prerequisite for almost all the softwares, whatever we are going to work. Okay, so make sure you have Java. Okay, how will you check whether Java is there or not? Right, right? Command Java space hyphen version one hyphen. Okay, you can see Java. Okay, like this. If you're able to get this one, that means you have Java, and it's the path settings, everything is done. Okay, so sometimes you wouldn't have set this Java path. Okay, but you would have installed the Java, but you wouldn't have set the path. Just make sure you have Java installed. That's more important. Okay, instead of this command, also installation is important. Okay, right. And so these two softwares has to be installed. Download it from here, and very straightforward. You know about Windows installation, I guess. Just download it, run, and next create the next. Okay, Visual SVN. This is for Visual SVN. Next, and then select this option. Okay, Visual SVN server command line tools, and add the subversion commands command line tools to the path. Okay, so that tomorrow if you want to work on the command line, for example, if you want to practice command line SVN, okay, so you can work on the command line also.
Yes, Subbu, can you share this document to us? Is that possible?
Right, definitely. That's what I'm saying. Okay, you will be getting the portal access. Let me give it right away. Okay, let me give the portal access right away. Can somebody log into the portal and confirm me now?
I don't have a user ID and password yet. I just talked to them today as well.
Right.
So,
So if you don't
so
have the user access, you have to get the user access and it should be added to the portal. Okay. Only then you will be able to access this. For time being, I can share this link. Okay. I can share this document in the email.
okay, that will be great.
Where should we check?
Go to log in your dashboard.
Is it the one they said DevOps intro?
Right. Exactly. Now, can you see VCS SVN also? Can you see VCS SVN also now?
I can only see the DevOps intro.
No. Refresh your page. You must be able to
Now
see.
I can. Yes.
Right.
Got it.
Right. In SVN, I would have shared this installing Visual SVN document. Can you take a look? Same document. Visual SVN installation docx. Okay.
Yes, got it.
Okay. So this is the document. Okay.
I'm sorry, Subbu, I cannot find it. I only have the first one. I refreshed it twice.
Just try to log in again or else refresh it. You will be able to see that. Okay. Because I won't give access for individual user. Okay. Give access for the group. You must be able to see. Whatever the others, everybody will be able to see, I guess. Okay, so I have uploaded this. Anyhow, for timing, I will share this link in the email. Okay, so just ensure while installing this SVN, Visual SVN online, especially the server. Okay, make sure this and then go for the standard. Okay, no need to go for the enterprise since we are free and give the by default it will come for like this. Okay, if you want to enable HTTPS, for example, in that case use a secure connection. Okay, so that the URL whatever you will be accessing this HTTPS, it will be a HTTPS URL. If you unselect this by default HTTP, it uses HTTP 80 port number 80. Okay, right, that is how we have to install this. Okay, very straightforward this. Okay. Hmm. Right. Once you have installed it, and Tortoise client, I have not taken any screenshot because it is even easy. It's even more easy. Oh, okay. Can you see my screen now?
Yes, Subbu.
Hey, I'm sorry.
Yes.
Right. So the Tortoise SVN is very straightforward. Just go ahead and install just like that. And as soon as you install Tortoise SVN, you just right click here. Automatically, you should be able to see this one. Okay, Tortoise SVN. Okay, as soon as you install Visual SVN, okay, go to the start, type Visual. Okay, Visual SVN Manager. You can see Visual SVN Server Manager like this. Open that one. Open that Visual SVN Server Manager. Okay, this is how Visual SVN Server Manager seems to be, and this is how Tortoise SVN seems to be. Okay, this is the server and this is the client. Any questions? Any questions so far? Everybody clear?
Subbu,
Yeah, go
the
ahead.
Yes.
client and the server will be installed on the same OS?
Right. You can install in the different missions. If you are able to connect both the missions, that is fine. In real time, we will be installing the server in one server. Clients will be all the developers' desktops. Client will be installed in all developers' desktop. Okay, server will be in one server. Okay, that is how in real time. But here we don't have multiple computers, right? So that's why we are installing both the things in the single server itself, single machine. Yes, we can install. Okay,
Got it. Got it.
right. Any other questions from anybody?
Subbu, if in Git, so there won't be any server, right? Like there is a GitHub repository. From there only
Exactly.
we.
Yeah.
Okay.
GitHub or GitLab or GitHub Enterprise. Okay, so these are all cloud-based platforms where you can store your Git Git repositories. Okay, so that is not a client server model. Okay,
Okay.
that is distributed version controlling system. Okay, this is
Okay.
centralized version control system, CVCS we call it as. Git is a distributed version control system, DVCS.
Okay.
Okay, that we will talk later. Okay, that Git will talk more deeply. Okay, right.
Okay.
So
Okay, Subbu. Yeah.
right. So this is how it seems to be. First step, what you need to do. First step, what you need to do here. You have to create the user. Okay, first you have to create the user. Create user. Okay, create user. Subu, so on so. Okay, like this. And then once you click it, you will be able to see all the users here. Okay, all the users here. Okay, then go for the repository. Then go for the repository. Right click on the repository is create new repository. Create new repository. Okay, so if you can see in the directory structure here, okay, every repository should have FSFS file system, right? So by default, regular FSFS file system. Let's take the FSFS, okay, which will be easy to restore, which will be easy to save, easy to track all the files also. This is the default file system. Okay, select that. Repository name, let's make this project name as Feb 2018. Okay, our project name is Feb 2018. Go for the next. Okay, and you want to create this repository as an empty repository, or you want to have the folder structure like trunk, branches, and trunk, branches, and tags. Okay, whether you want empty one or you want to have these folders by default. Okay, so choose this one. Okay, anything is fine. Anything is fine. Okay, if you want to go for your own folder structure, you can go, but SVN recommends to have these three folders always. Okay, these three folders always: trunk, branches, and tags. Go for the next. And all subversion users have read and write. That means whatever the user you have added, all the users, or nobody has access, or customized permission, custom. Okay, add only the respective users. Okay, like this. Let you give the permission to this all. Okay, create. Okay, you will get one URL here. You will get one URL here. Copy this. You will get one URL here, and everybody is having read and write. Okay, so this is the URL where we have to share this to the development team. Okay, what development team will do next? Okay, development team will go into their server. Will go into their server. Okay, they will. Right, they will go to their workspace. Okay, their workspace, and they will go to the tortoise SVN. Okay, and then sorry, you can go here SVN checkout. Okay, you can see the option called SVN checkout here. Click on the SVN checkout. From where I need to check out? I have to check out from this one, Feb 2018. This is a URL one, right? Automatically it will copy that from the clipboard. Automatically, whatever the URL is there, that will be copied to clipboard. From the clipboard, it will take it. Okay, and from to which directory I want to check out. To which directory I want to check out. Okay, make sure that this URL is correct. Click OK. Okay, right now our repository version is 1. Okay, see this, our revision number 1. Okay, right, this is how you will be able to check out. Okay, you can see in the server also, in your Feb 2018, you can see only these 3 folders. Yes or no? These 3 folders are there: trunk, branches, right? That is how it seems to be. Any questions so far? These are all the small basics. If you don't understand these things, you will not understand the future concept. That's why I want to make sure you guys are understanding, you guys are following me. Everybody, any questions? All clear so far? Right from the installation, concept, and checkout,
Yes,
creating the
Subbu.
repository, creating the user.
Yeah, Subbu, it's clear.
Right, very good. Right, okay. Right, perfect. Right. So once he has checked out, okay, let's practice this model. Okay, let's practice this model, stable trunk. Okay, so what we'll do initially, we'll start work on the trunk itself, and then we'll create the branch. We'll create the branch, do the changes, and then again we'll merge it and create the branch, do the and merge it. Okay, let's practice this model. First, let's work on this one. Okay, this topic. Okay, so let's start working on this trunk. Okay, let's create a small Java file here. Okay, so okay, so this is my file. Okay, this is my Java file. Okay, so import java.io.start. Okay, you know, right? Java program. You can write anything. Okay, it doesn't mean you should always use only Java code. Okay, import java.io.start. Yeah, every statement should end with semicolon, public class work, hello world. Okay, make program as simple as possible. Right. Okay, let's save this file in our repository. Where is our repository? It is in SVN workspaces trunk. Okay, always you should save hello world.java. Right, so I have a program here. I have saved a file here. Okay, and the thing here is, as soon as you save it doesn't mean it's a version file. Okay, it's a, by default, all the files which you saved here is non-versioned file. It's a non-versioned file. Okay, so this one you should add to the local repository, that is your .svn. If you can notice here, .svn, it is a hidden directory. As soon as a developer check out the repository to the workspace, it will create .svn. If you delete this .svn, you will not be able to interact with the server, and you will not be able to track all the changes which are doing in your local. Okay, so this .svn is very important. Okay, this is like in your architecture. Okay, the client library, repository access, SVN, so this middle one. Okay, this middle one, that is .svn. Right, now I have created the file. What should I do next? I Okay, is this available in the server? No, right? It is still not available. Okay, how to make it available? How to push these changes to the server? Right, I have not yet pushed. Let's see. So to push the changes, first you have to add it. Okay, tortoise SVN. Go to tortoise SVN. Where is that? Yeah, tortoise SVN and add it. Go to the add. Right. As soon as you add it, it will show the small plus symbol here. Okay. So that means this has been added. And also if you can see the repository, sorry, that trunk, the directory, some red color symbol, right? So that means there are few changes being done in this directory. There are few changes being done in this directory. Either file has been added or deleted, but these are not yet committed. These are not in the sync with the server. Okay. So now, as soon as you add it, does that mean like file will be copied to push it to the server? No, right? So we just add it in the local repository. Okay, in the local only. Okay. Now what we need to do, we have to commit SVN commit. Okay, how to commit this? Well, just right click here, go for the SVN commit. Okay, so you have to give some comment here. Always it's a good practice to give the reasonable, the correct comment here. Okay. Hello world. Okay, right. Click OK and click OK. Now, if you can see that plus symbol has become green color. This is very small ring, right? Yeah, hope you can see now, right? The green color symbol. Here also you can see the green color, right? Now, if you can go to the server now, just refresh it here, you will be able to see the file here. Okay, if you want to browse it, you can browse it to see the data. Okay, you for browsing also you have to give URL. See this, the content whatever you have given here, right? That is how we can add the files. We can add the files to the repository and do modify. Right now I have some fix. I have some bugs. I need to modify this. Okay, so what I need to do, I will modify it here. Okay, so okay. Right. So I have modified some changes. Okay, I have modified for some specific bug. Okay, so as soon as you modified, it has gone to red color. That means there are some changes which are not yet committed. So how to commit again? Commit it. SVN commit it. Okay, and again bug number 001. Click OK. Now it will be in the green color. Now you can see that in the server also. Okay, refresh it again. You can browse it. You can see the some catchy symbol, some catchy needs to be cleared. I think that's the reason it is showing like this. Okay, so it is a catchy problem, not an issue. Okay, so the file has been committed to the repository. Okay, so so this is how we can modify some changes and commit the code to the trunk. Okay, so now if you want to see the history, okay, so SVN commit, SVN update. Let me explain about SVN update. It's a reverse. You can see the reverse arrow symbol here. SVN update means, for example, I have modified some changes, deleted something. If I update it, if I update, automatically I'll get the latest copy from SVN server to the local. Okay, I'm deleting it, or um, you want to sync this with the server. You want to sync this workspace with the server. SVN update. Automatically, you will get the latest version from the SVN server to local. Okay, so update SVN update means getting the server changes to the local. SVN commit means pushing the changes from local to server. Okay, right. And if you want to see the history, okay, show log, you can see all the logs here. Okay, you can see the difference between two versions also. Compare revisions. Okay, what was the change? What was the previous one? What is the current one? Version number 3, version number 2. Okay, like this. We can also compare what are the lines have been modified, like this. They can also modify different versions and of each and every file. They can also see the complete track, and they can also see from which date, okay, from the respective, from one date to another date, what are the history. This is actually the log messages. What are the log messages? By default it will show entire all the date. If you want to filter, okay, um filter like added. Okay, wherever added is there, it will show it here. Okay, this file is been added, right? So it will search all the properties, and it will filter it here. And also if you want to search, okay, who is the author here? Okay, who is the author here? Subbu. So like this, you can also, it's like a grep command. You know grep command, right? So grep will, what will it do? It will filter the text. Same way, it will also filter. It will also filter the thing here and show the logs here. And from the, if you want to go see the logs from the one range, one day to another day, you can select the dates. Okay. So that is how we can see this. And go for the statistics. Okay, go for the statistics and number of days, how many days, number of authors, how many authors. So like this, you can most active user, more, okay, active author, least active author. Okay, file changes every day. How many files been changed? Okay, like this, you can also see the statistics, commits by date, commits by author, commits by, okay, percentage of authorship. Okay, like this, we can also take the statistics. Okay, these are, we can also take audit kind of reports also here. Okay, this will help us to track all our changes. This will help us to track all our changes. Okay, right. And now let me explain about few more things here. Check for modifications. For example, you have done some changes. Okay, done some changes. Okay, if you go here, SVN, check for modifications. If you go for this one, what are the things have, what are the files have been modified, and what are the changes? Okay, what are the files have been modified? Those modified lists you can track it using this option. Check for modifications. Revision graph. Okay, so how this trunk and branching structure flow is happening. This, the graph will show you graphical structure of your branching structure. Okay, and resolve is for, especially we will talk about when we resolve about conflicts. Okay, we'll talk later. Update to the revision. Okay, update to revision. For example, you want to roll back, to previous revision. You want to roll back to previous revision. I have done some changes. I want to roll back to previous revision. Update to revision. Update to the revision. Revision number or head revision. Okay, or revision number, specifically revision number 2. For example, click OK. Automatically, this file will be rolled back. Right, I have to select the file and do this. .svn. update to revision number 2. Now you can see the file has gone to revision number 2, and if you can see that bug number 001 that is not there, that changes have been, that delta has been deleted. Yes or no? Okay, so that is how we can also go back to the previous line. If you update it, automatically you will get the latest changes to here. Okay, there are some conflicts here, that's why you are getting this error. Okay, leave it, just go for the SVN update, you get the latest copy. Right, I will explain about the conflicts later. Okay, right, and now you still have this second line, right? Very good. So now revert who you understand. Clean up, for example, you have some additional files. Okay, additional text. If you want to clean up all unnecessary files in your workspace, okay, so clean up. Okay, clean up, delete all unversioned files and folders, delete ignored files. You can select these options. Based upon the options, it will clean your workspace. Okay, all unversioned files has been deleted. And Torres SVN, go to the lock and release lock. Okay, lock and release lock. These are the features to lock your files. Okay, so for example, I'm modifying the important configuration file. One important configuration file. Until and unless I commit it, nobody should modify this file. In that case, you can go here and go to .svn, and you can get lock. You can lock this file doing some important change. Okay, I have logged it. Okay, if somebody is trying to do some changes here, okay, for example, we have a developer 2. Go here, he will also write, he has to check out, right? Copy URL to clipboard, but is check out, click here. If he is trying to commit his changes, okay, test log, commit, okay, test log. See this, he is getting the error. It's logged by another user. This is logged by another user. Okay, so you some others cannot do modification, do commit until and unless he commits the changes. Whereas if he is trying to commit, okay, if he is trying to commit, okay, so he will be able, right? Oh, I'm still in development too, right? Let's go to the developer one. This is the developer one, right? If this guy is trying to commit, okay, commit, he will be able to commit the code. After that, if you go to the developer 2 can do the modification. Developer 2 commit, okay, dev 2 commit, he will be able to commit this now. Okay, some conflict that we will discuss later, right? Right, this will discuss later. Okay, you will not done the right. So I hope you understand what is lock and unlock, right? And and branch that we'll discuss later. Switch from one um, switch from one branch to another branch. Switch from your workspace can be switched from one branch to another branch, okay, using switch command. Okay, that's also a very simple option. So this is how you can use these options. This is how you can use these options. Okay, and let's see a few more features here. Okay, how to create the branch. How to create the branch. As per this, okay, we are creating the branch, right? Do the changes again and merge it. Now let's see how to create the branch and do the changes and commit the changes back to the trunk. Okay, let's practice this now. So to create the branch, let's assume we have done the changes here. Everything is done. Now we are going to create the feature branch. Okay, feature one branch. Okay, so to create the branch, go to the right click on the server, right click on the trunk, go to the tortoise SVN, go to the branch or tag option. Branch or tag option. Okay, and two path. Okay, what is a two path? Two path should be, where should I create? I should create inside branches slash, okay, Feb 2018. Maybe you'll get confused, or feature or release one, or Feb release. Okay, Feb release. Okay, log message. This is for February future changes. Okay, so I'm creating the branch here. Okay, you can go inside of the branches SVN update. You can see the changes here. You can see the code came here. Okay, now let's assume he has more. He has also added some file. Okay, Feb release. Feb release. Okay, he has more added some file. SVN commit. Edit. Commit it. Okay, done changes for February release. Okay, where I'm committing? I'm committing in the branches. Okay, in the branches. Okay, this file is only in the branch. It is not there in the trunk, right? Okay, now let's assume this code has gone to the ITG QA search production. Okay, this code is working fine. Now at the end, what he needs to do? Okay, so you have a repository. Okay, you have created a branch, you did some changes here, it went till the environment production. Then what we need to do, when it has gone to the production, we should always make sure our latest changes are in the trunk should be overall changes. It should contain the latest changes of all branches. So commit the changes back to the trunk. Okay, so let's commit it. Okay, so let's merge it. It's not a commit, honestly, it's a commit. Okay, so now let's merge the changes to the trunk. Okay, how to merge it? Okay, go here, tortoise SVN and merge. Okay, go for the merge. Go to the next. Right, sorry. Let's go to the branches. Right click on this one. Go to tortoise SVN. Go to merge. Okay, go for the next. Oh, I'm sorry. So I should go to the trunk only. Always go to the trunk, tortoise SVN, merge. Okay. So URL to merge from where you have to merge. Okay. Select the branch. Which one I have to merge? Okay. This is the one I have to merge to trunk. Okay. Go to the next and merge. Now you should be able to see this file. Okay, then again you have to commit this. Okay, you have to commit this. How to commit? Right click and SVN commit. Okay, commit after merge from fab release branch to trunk. Okay, so what is it showing? It is showing out of date. Okay, your directory is not up to date. Update it. Click OK. Click OK. Now it has updated. Okay, right. So that is how we can merge the changes. Okay, we can create again. What we need to do, we have to create one more branch. Okay, so we have merged it, and then again we have to create one more branch. Okay, merge release, do the changes, deploy it all environments, then merge it back to the trunk. Okay, so clear everybody? Merging clear everybody so far?
Yes, Subbu. Yes.
Everybody?
Yes, Subbu.
Yes, Subbu. Yeah, Subbu.
Yes.
Harjinder, Pradeep, Santosh, clear? Right, perfect. Now let's take the one more important thing. Okay, now for example, if you can be developer 2. Okay, uh, let's have one more directory called developer 1. Okay, developer 1. Let's check out here also. Check out this one. Right, to avoid the confusions, I'm taking two directories. Okay, each directory it says a developer. Okay, this is a developer 1 workspace, this is a developer 2 workspace. Okay, now developer 1, take it as SVN update version number 8. Okay, and developer 2 update SVN update version number 8. Okay, so I need your concentration for another 15 minutes. This is logically very important to understand. Okay, what is conflict? What is conflict? When will we get the conflict? Okay, so let me explain the subject here first. So you have a repository. Right now it is in the version number 8. Okay, developer 1 also in the version number 8. He is also at the version number 8. Okay, so developer 1 and developer 2, developer 1 and developer 2. Okay, so now developer 1 has done some changes. On top of this version 8, he has modified some changes. Now he has committed these changes to the repository. Then it will become version 9. Agree? Here also 9 and here also 9. Agree everybody? Then parallelly, if he is trying to modify this version number 8 and commit it, if he is trying to modify version number 8 and commit it, he will get the error, out of date error, out of date, because he has not taken the latest copy of repository. Okay, let's see this now. Okay, till here. So developer 1 is trying to modify this file. Okay, demo out of date error. Okay, so commit developer 1. Okay, developer 1 is doing right. It is now at the 9. Right, now if you go to the developer 2, if he is trying to commit something, okay, dev 2 changes. Right. Now he is trying to commit it. Okay. Dev to changes. Okay. It will throw, or it's called as out of date. Are you noticing this? Okay. Error, out of date. So what is the solution for this? Right. What is the solution? It's very simple. Just update your workspace. Okay. Update your workspace. Okay. Click OK, and it will ask, you want to update? Yes, update. It is updated to the version number 9. Okay, and now it has thrown some conflict. Okay, jump the conflict. So what happened here? Okay, so what the thing here is, it has developer 1 has updated the changes as demo of this one. Developer 2 updated as developer 2 changes. Okay, so same file at the same line. Both the developers has done the changes in the same file and in the same lines. Okay, so now it is not able to resolve this. Okay, when it is trying to update his workspace, whether it has to keep server changes or developer 2's local changes. server changes are saying the Server changes are saying these are the changes, his local changes are saying developer 2 changes. Got it? Okay, so which one I have to keep it? Okay, so you have to select this. Okay, use this text block, use this whole block, use this text block mine before this. Okay, use mine before this, or use this first after mine. Okay, like this. Select this option. Okay, modify this and then mark as resolved. Mark as resolved. Now go for the click OK and click OK. This is how we have to resolve the conflicts. Okay, conflict will come only when multiple developers, when two developers works in the same file in the same lines. If developer 1 works on the different line, if developer 2 works on the different lines, you will not get the conflict. Okay, you will get the conflict only when you modify the same files in the same lines, that too at the same time, okay. So to avoid these conflicts, it's always good practice, to take the updated version, and modify this. Okay, so what happens here? So here's 9, and when he is trying to update this 9 to here, okay, when he is trying to update this 9 into here, he got the conflict, okay. So to resolve this conflict, okay, we have opened one window and use this mine there like that, and resolve this conflict, and merge the code here, then push the version to the here and make it as 10 here. Okay, so now it has 10. Okay, here 9 become 9 plus his changes 10, like this. Okay, well, if he wants to get these changes to here, what he needs to do? He has to do SVN update. Okay, SVN update. Okay, it won't come for the tree conflict. Okay, it's not a tree conflict. I didn't get your question. What does it mean? Does it comes under tree conflict? It's a code conflict. Okay, let me show you again. When this error comes. Okay, developer, this is developer 1, this is developer 2. Let's take the same copy. Let's take the SVN update. He is at the 10, he is also at the 10. Okay, both are the same. Developer 1 has done some changes. Developer 1 did changes first. Okay, save it, and he also has done some changes. Developer 2, dev 2 also did some changes on revision number 10. Fine, but this guy has committed his changes first. Okay, the one committed changes first. Click OK. Now the version become 11. Okay, now this guy is trying to commit. Developer 2 is trying to commit. Developer 2 is trying to commit post developer 1 commits. Okay, click OK. So he is getting out of data because he worked on the version number 10, but current version in the repository is 11. Okay, so that's why it is showing out of error, out of data error. Now click OK. When he is trying to update this, okay, when he's trying to update this, okay, he's getting the conflict because here both have modified the same line number 12. Okay, so use these options, use this block mine before this. Okay, take this first, then mine later, like that. Take whatever the option, use this only block, use this only block, or whatever the option is. Okay, or if you want to modify this also, okay, you can modify like this also, and then mark as resolved, mark as resolved. Click OK, then click OK. That's it. Okay, now revision number become 12. Okay, this is how we will get the conflict. Okay, usually who is responsible for this resolving conflict? Okay, developers. Okay, developers are, it is their regular work. Okay, resolving conflicts, resolving, committing, merging, all this. Okay, so but as an SCM engineer, you should also be aware of all these changes. You should also be aware of all these changes. If they want their guidance, if they want, sometimes what happens in few projects, you might have to educate the team about version control usage. This is how you have to use, this is how you have to create the branches. Okay, so on, so right. You might have to educate also. Okay, you should be on top of them, right? Okay, so this is how you can create the branches, and you can resolve the conflicts also like this, right? We understand the branches. Now let's talk about the tags. Okay, how to create the tag. Okay, let's assume we have reached some milestone. Okay, we have reached some milestone. It's always good practice to take the SVN update and then start doing, because we want to sync my local workspace with the SVN server. Okay, good to update and then go ahead. So how to take the tag, how to create the tag? To create the tag SVN, go to the branch or tag. Okay, then where should I have to create the tags? Okay, two path. Okay, so tags slash okay, snapshot 01. Okay, we have successfully implemented online banking. Example, just saying. Okay, let's assume this is a one milestone. This is one milestone. Okay, click OK. Now go to the tags. Let's see an update. You'll be able to see this snapshot 1 code. Okay, anytime in future, you can always get the code from snapshot 1. Okay, right. Can I do the modifications in tag 1? Can I do the modifications and commit? Right? Do changes in tag. Right? Shall I SVN commit? Okay, so commits in tag. Click OK. It will throw warning. Okay, your working copy points to this, which is appears to be a tag. Okay, so that is not a good practice. To commit in tags always, because tags are snapshots. These are backups. If you keep modifying the backups also, what is the use of backup again, right? So it's not for modifications. If you still want to modify, you can modify. Okay, you can modify. Let me roll back all my changes. Okay, so revert. Okay, click on select revert, click OK, so that my modification will be reverted. Okay, that is how I can also revert these changes, right? Let me if you want to switch this repository as trunk and switch from trunk to snapshot, for example, click OK, automatically your repository will be switched. Okay, like this you can switch between the branches and tags. Okay, switch to trunk. Okay, my working copy will be switched to trunk now. That's how you can switch. Okay, right. I did some modifications. Okay, my lead is in sitting somewhere else. Okay, so what we'll do, I want to check my code changes with him. Okay, what I can do here is I will create patch. I will create patch of my changes. What is patch? Generally a update on top of something. There is a small update. Windows patch. Okay, Android version patch, iOS patch means some fixes, right? So some changes. Okay, even if it contains some more subdirectories, anything, whatever the changes you did, all the things comes here. Okay, but for what are the files you want to create the patch, that you have to select. For what are the files you want to create the patch. Okay, select this and create okay, trunk patch. Okay, like developer 1 trunk patch. Okay, I'm saving in the dev1 trunk itself. Okay, save it, click OK. Okay, now developer 1 in the trunk I have this patch. What I will do, I will share this file with the developer 2. Okay, what developer 2 will do here, he will go here in the trunk and he will go here and apply patch. Where is this one? It is in the developer 2, this one. Apply this patch. Okay, so select this each file, okay, change to 200, this is 100. Okay, so then save it. Okay, so now this is how he can apply the patch. And see the modifications. He will review the code and he can confirm back the changes here. Okay, and then he can commit the code. Okay, so we can apply the patch is a combination of your changes set of files. Okay, if you can see this file, if you open this patch, you can understand. Okay, this is the patch of this, if you apply, you will get these things. Okay, so you will apply this patch and see the changes here. That is how you can use these patch options. Okay, right. And if you want to do some settings in the tortoise SVN, right, colors or icon set. Okay, icon set issue sometimes comes in Windows. Okay, sometimes in Windows we will not get this green color tick marks. Okay, in that case you have to go for tortoise SVN and settings, modify this, and about will show you the version of this tortoise SVN, so on, so right. So this is how we use tortoise SVN and visual SVN as a server, client server model. Okay, I hope you all understand the basics of version management, basics of version SCM process, and understand the history of SCM, and what is trunk, what is branch, what is parallel development, what is tag, what is version, what is delta, what is rollback, right? How to roll back, what is log, how to see the history, and parallel development, merging, conflicts, right? And we have also gone through the practical session of creating everything here, right? Everybody clear? Okay, so just few more minutes, let's go through the remaining slides and then we'll close the session for today. Okay, properties, binary versus, right? So lock, modify, unlock, I hope you know, right? The user, what are the file he want to modify? Yes, lock and unlock also we have practiced, right? Copy, modify, merge. Okay, this is what, how did we resolve the conflict? Okay, developer A, user B, working copy, user A gets commit copy, and A tries to commit into the A is okay, A is trying to save commit, and B tries to copy and failure because he wants to modify this stable version, update this, and then resolve the conflict. Okay, we have whatever the practice, the same thing is available in the theoretical manner here. Okay, and copy, modify, merge will help you to enable a parallel development. Okay, this is a practice. Okay, and revision, subversion transactions are atomic. As we have said, it's a atomic. Every revision it will increase the version 0 1 2 3 4 4 5 like this. Okay, so every revision number 0, these changes, 1, these are the changes, 2, these are the changes, like this. Okay, and revisions and working copies, every working copy, every time you change that, okay, it will create one, revision. Okay, and state of working file state, unchanged and current, so working file, you have checked out, there is no change in the working file and it is up to date. Okay, that means it is up to date. State locally changed and current. Okay, locally modified and it is up to date with the server. Unchanged and out of date, you have modified this on the old revision of repository and it is out of date. And there is a new version in the repository. Locally changed and out of date, right? You have unchanged and out of date. Unchanged and out of date means you have not changed anything, but your repository is out of date. Okay, locally changed out of date means yours is out of date, but you have done some changes in our local. Okay, so what will happen based upon the state? Unchanged and current. Okay, if it is up to date, if you update it, it does nothing. Commit it, it does nothing because there are no changes. Locally changed and current, you have modified some changes and it is current one. When you update, it won't do anything. When you commit, it will modify your changes, it will push your changes to the repository. Unchanged and out of date, when you update, replaces working file with a new one. Okay, with the new one, whatever the changes, okay, and does nothing when you commit it. Locally changed and out of date, it need merges into the working file. Okay, and commit, operation fails with the out of date error. Okay, when it is out of date, you try to commit it, it will show the out of date error. Clear everybody this slide? Clear everybody?
Yes, Subbu.
Yes, Subbu.
Right, and this is how we do work with the SVN. Okay, if possible, okay, we'll try to see SVN commands in the next session. Okay, SVN commands, how to create the repository, how to commit it, how to check out, how to check in, how to see the log. Okay, all these things. We'll also see command lines. Okay, usage of command line, and